Hey, this is Madan sir here, and I have come up with another video, and like most of you may be aware, that this is going to be the next part of the electrochemistry. So this time I'm talking about measurement of conductivity of electrolytic solution. I tell you what, I've already explained you what is an electrolytic solution. A solution containing electrolyte. Basically, a solution containing salt that dissociates into ions is called electrolyte solution. First thing, I'm considering to tell you is about measurement of resistance. The first thing I'll be discussing, measurement of resistance of an electrolytic solution. Electrolyte solution. What second thing I'll be talking is about conductivity. Second thing will be problem in measuring resistance of a solution. Third, I will be talking, and its resolution. Third, I will be talking about conductivity cell. And the last thing in today's video is going to be about cell constant. Right? So these are the topic, I wanted to, go as I have planned, right? The first one is, we need to find out the resistance of a solution. Only then we'll be able to find out the, conductivity of the solution. But there are some problem in measuring the resistance of a solution. We will be coming to that. Then we'll be talking about the solution of resolution of that. Finally, we'll be talking about conductivity cell and cell constant. So let's, do it one by one here. So the first one is measurement. Or the first thing we need to tell you that Wheatstone bridge is an instrument. Wheatstone bridge. Probably most of you know what this is. It is an instrument. It is an instrument used for measurement of resistance of both solid and liquid. So what is Wheatstone bridge? It's an instrument which is used for measurement of the resistance of an instrument. So for what you know, that resistance is a property that actually is nothing but an obstruction in the path of the flow of current. But the instrument that measures the resistance is called Wheatstone bridge. Now, an electrolyte solution and a solid has a very clear difference. A solid can be directly connected to a bridge because they both are some object. They both are some solid thing, so they can be connected with some physical instruments and physical activity. But a solution cannot be connected. So there are two problems, but the measurement of resistance of an electrolyte solution face two problems. What do it mean? To find out the resistance of a electrolyte solution, we have two problems that we have to go while we measure it. First, we cannot connect it. We cannot connect the solution with Wheatstone bridge. I'm writing here in short, Wheatstone bridge. What that means? We cannot connect the solution with the bridge. Second problem is that passing DC current through the solution can change the composition of solution. Can change the composition of solution. So let me repeat back the whole thing. When we have to measure the resistance of a solid, there is no problem. We can connect it and we can measure it. But when it comes to measure the resistance of an electrolytic solution, there are two problems. One, we cannot connect it. We have connection issues. And the second, if we pass DC, the solution may undergo some sort of reaction and the composition will be destroyed. So what are the resolution then? There are two simple resolutions are there. First, so now resolution. I'm talking about the resolution. Resolution may sound different to different people, but right now it's about what are the solution that has to be done in order to resolve those problems. So the first problem, is that connection problem is resolved by using a conductivity cell. So that's a conductivity cell. So that's a different kind of cell you have, come right now. So what that means? There was a problem how you were going to connect a solution with the Wheatstone bridge. Now you have an instrument. I'll tell you what that instrument is. But now you have an instrument. With the help of that instrument, you can connect the solution. Now, second is using AC in place of DC. In place of DC does not change the composition of the solution. So we have these two solutions for the two problems. I repeat back, there were two problems. One is with the connection problem, other was using the DC. Now you can use a conductivity cell, specially designed, I'll tell you right now. But other problem which is of using DC, you can change the DC in, you can use AC in place of the DC. So that's the two solution. But with that we have come to another topic, that is conductivity cell. We have now conductivity cell. Conductivity cell. I've already told you the purpose of this instrument. The instrument actually provides a connection to the liquid solution. So let me write this. Provides connection with a solution to Wheatstone bridge. Wheatstone bridge. Let me repeat back. This is an instrument which actually resolve a problem, and that problem is how you are going to connect it. Now you have an instrument, you can place that solution inside that instrument, and then you can easily connect the Wheatstone bridge to that. So what is this? There are several designs of, I'm telling you, there are so many designs of conductivity cell, but two of them has been given in your NCERT book. One of them, it's something like this, right? So there is a structure something like that. So what it has two platinum electrodes here. These are two platinum electrodes, right? Let me write. It's a platinum electrodes. This one is also platinum. Both of these platinum electrodes are coated with platinum black. Both of these are coated with platinum black. So I am not that very much good in terms of drawing. So I'm just trying to make it, coated with platinum black. coated with platinum black. Now, in this particular instrument, what you need to do, you can fill up the solution where you needed a connection. So what inside is electrolyte solution. Electrolyte solution, which initially was not possible to connect, and there with these two terminals you can connect the Wheatstone bridge. But I'm not going to that. I'm just letting you know what conductivity cell is. It is an instrument that helps in providing connection to the electrolyte solution with the Wheatstone bridge. Now, what it consists of? It consists of two electrodes. Both of the electrodes have been coated with platinum again, and the container has been filled up with the electrolyte solution. Now, concentrate here. Suppose the distance between these two electrodes, these two electrodes is L here. So L is the distance between the two electrodes, and suppose the area is, just give me a second. Okay, so sorry for that. So suppose L is the distance. Let L is the distance between two electrodes. And A is their area of cross section. So you need to concentrate here. A and L. L is the distance between two electrodes, and A is their own, area of cross section. Now, the thing is that R is equal to rho into L upon A, right? So that is the formula of the. Now the question is, with this formula we can find out L by A. Now what I'm going to do is, if L is the, if L is unity, what that mean? 1 centimeter or 1 meter maybe, then this becomes rho into 1 by A. Question is, if you remember what this K was, this is your conductivity. What A is here? Area of cross section. Okay, let me repeat you the whole thing. We were talking about a different kind of cell. It's called conductivity cell. Conductivity cell is basically aimed to provide connection with the electrolyte solution so that we can find out the resistance using a Wheatstone bridge. How does it, how exactly it consists of? It consists of two platinum electrodes having distance between them L, and their own area of cross section is A. Now they have been filled up, they have been surrounded by the solution to which the resistance has to be measured. So this is the entire setup, which is called conductivity cell, and there you have the electrolytic solution. And I've explained what L and A are. Now there is the mathematical part here. R you do know is equal to rho into L by A. If L becomes unity refers to 1. If L becomes unity, this becomes rho into 1 by A. What rho is here? It's the resistivity. You probably know that. And then there is, in case we solve it, what we get? We get R equal to 1 by Ka. K is the conductivity. I hope you understand. And what conductivity is, in case you have forgotten, conductivity is represented by K, and that is equal to 1 by rho. So this is the conductivity. So there we have this conductivity cell. Now I have to take you through the last topic, which is the cell constant here. So the last thing is that it's cell constant. Cell constant is basically represented by G with a star up here. Don't get confused if you see G for conductance also and G star for the cell constant also. Now it is defined as defined as ratio of, defined as length or distance between the two electrode, distance between two electrodes, in the conductivity cell, divided by area of cross section, So what that means? G is equal to L by A. So this is the formula right here. G is also equal to R into K. How this is coming out to be? You just need to, dig a little bit, by on your own. What we have to do over here, we just need to, solve them, and you will get it to the R into K here. So G star is also calculated as cell constant. So different, conductivity cell has different cell constant. Maybe one is larger, so it has different cell constant. One may be smaller, so it has different cell constant. Just give me a second. I want to check whether, there's something else I'm missing, or it's already, done here. Yeah, so this is, like almost done. The topic I was concerned, today to complete. I have almost done it, and I hope this is going to be useful. But let me, wind this video right up here. And I would say, this was another video in very, very sequence. And the next topic I'll be talking is going to be what is the effect of dilution on the conductivity and molar conductivity. But you just let me know how good or bad, everything is going. And one thing, just keep watching and take care of yourself, take care, all those who care about you, and most importantly, don't forget, that humanity is what we are, serving for. This is the first time I'm saying something about this, so let me, tell you a little bit of that. Humanity is what, my life purpose is. What I'm like, I can't, imagine a life without, serving the humanity. So I'll tell you, else about in upcoming time, in case you have interest, and let me know about. Anyway, thanks for watching.